Hi everybody. So I am going to do some videos for pre-algebra. So I'm going to do the first section, which is 8.1. I'm going to do just the first two examples. So for the first example, we need to identify the domain and range. So when they ask you to identify the domain and range, you have to realize that the domain represents all of your x values, and the range represents all of your y values. So all you do is list them out from least to greatest. If a number repeats, you only do it once. So our domain is 1, 2, 3, 4, and 5. None of our number repeats. Then for our range, 23, 36, 47, 61, and 73. And none of those numbers repeat. So that would be our final answer for the first one. For the second one, they want us to tell whether the relation is a function. Relation is referring to our x and y values together. So to determine whether or not the relation represents a function or not, you look at your x values. If none of your x values repeat, which they don't, then this represents a function. For the second one, when we look at this relation to determine whether or not it's a function, again, we look at the x values. Well, if you notice, 2 of the x values repeat. There's 2 -2s, and the y values are also different. Therefore, this is not a function. So that is 8.1. Now we're moving on to 8.2. (8.2) is linear equations in 2 variables, and I'm going to move on to that example. Looking for my marker. Okay, so for example 1, it says tell whether the ordered pair is a solution of this equation. So for our first one, 2 separate ones, they give us an ordered pair. An ordered pair represents an x and a y, but we're going to take those values and plug it into our equation. So we have 2x minus y equals 5. We're going to substitute in our x and our y to see whether or not this is a solution to our equation. So 2 times 1 minus, that's there because of the equation, and then our y value itself is -3. And then we simplify. 2 times 1 is 2, a negative, and a negative gives us a positive. When we simplify the left, we get 5 equals 5. Since we got a true statement, therefore, that ordered pair is a solution to the equation. For the next example, we have another ordered pair. Again, this is an x, this is our y. We're going to take it and plug it into our same equation. Substitute in our x, 2 times 4 minus 7 equals 5, and then we simplify the left. 2 times 4 is 8. 8 minus 7 equals 5. Well, 8 minus 7 is 1. 1 does not equal 5. Therefore, that is not a solution. So that is example 1. I am skipping example 2 and moving on to example 3. For example 3, they want us to graph a linear equation. So this is the first method on how to start graphing. And the first method that we learn is by making a table. You make a table. Doesn't really matter what values you use. You could use 1, 2, or 3, but I always like to use a negative value, 0, and a positive. We could use -2, 0, and 2, but just to make calculations easier, I like to always pick -1, 0, and 1. Now we're going to take those x values, plug it into the equation, and figure out our y. We have y equals 2 times -1 minus 1. And then we simplify. 2 times -1 is -2 minus 1. Same sign, you add and keep the sign. So that's the value of our first y with that x. Now we're going to take this x value and plug it into that equation. Y equals 2 times 0 minus 1. Well, 2 times 0 is just 0. 0 minus 1 is -1. Then we take our last x value, which is 1, and plug it in. 2 times 1 minus 1. And we simplify. 2 times 1 is 2. 2 minus 1 is 1. I like to put my table this way. That way, we have our ordered pairs right away. So we're going to plot our first point. -1, -3. 1, 2, 3. That's our first point. Now we're going to plot our next ordered pair, which is 0, -1, right on our y-axis. And then our last point, which is 1, 1. 1, 1. When you connect the 3 points, you get our linear equation. If you don't get a straight line, you did something wrong. So that's example 3. Now we're moving on to the last one from this section, which is example 4. So the previous problem, we graphed an equation, just to refresh, that has a y value and an x value in the equation. That's why we get this straight line with a slope involved. When you graph only, with one variable itself, like these two equations are, that's when you use that famous little thing, Hoivux. This is for graphing purposes, and it gives you some clues. So when you're dealing with the y, you're going to use Hoi. Match your variables, y and y. That means you're going to have a horizontal line, a 0 slope, right on the y-axis. So we're going to graph the first one, y equals 3. You're going to go to where y equals +3. Remember, only dealing with the y-axis. 1, 2, 3. So that's where y equals 3. But we're not plotting a point. We are graphing a line. That's where this comes in. This h is a reminder that it is a horizontal line. The slope is 0, and it's right on the y-axis. For this graph, where it's just the x value, we're going to use Vux. We're going to go to where x is equal to -2, right here. This is our x-axis, right to where x is equal to 2. That's our point, but again, we're graphing a linear equation. So this Vux is our clue. Vertical line, we're going to draw our vertical line. The slope is undefined, and it's right on the x-axis. So that's when you graph with only one equation. So I'm going to pause so I can get ready for the rest of the... I kind of like cut myself off as I was saying that I was pausing the video. That way I could erase all the boards and start with the next section. So now we're going to start 8.3. 8.3 is solving for intercepts or using intercepts. So this is the next method that we learn when it comes to graphing. So the first example shows us how to find the intercepts algebraically, and then we learn how to graph using the intercepts. So in the previous section, we learned our first method of graphing, which is you make a table, you pick the points, you plot those ordered pairs, and you get your line. So I got cut off, internet went out. Let's see if it continues to work. Let's see. So I had ended off with 8.2, and I was starting 8.3, which is finding the intercepts. So we solve for the intercepts. I'm not going to use that one. I'm going to use this one, which is another method of graphing. We solve for the intercepts first, and then we use those 2 points to graph. So we need to find each intercept. So we're going to find our x-intercept first. When we solve for the x-intercept, at that point, y is equal to 0. X-intercept meaning it's where it touches the x-axis. So any point on the x-axis, it has an x value, but the y is equal to 0. So that's how we're going to solve for our intercept. We're going to take our equation and substitute y as 0. Well, that just goes away, and then we're left with 3x equals 6, and then solve for x. Divide by 3, divide by 3. So we have x is equal to 2. Well, when you use that, it's together with the y. So together it's an ordered pair, 2, 0. Well, now we need to find our y-intercept. When we go to find our y-intercept, at that point, x equals 0. Anywhere on our x-axis, which is our vertical axis, it has a y value, but it has no x. X is equal to 0 on that point. So when we use x as 0, we can plug it in and then solve for our y. So 3 times 0 minus 2y equals 6. This just goes away, and we're left with negative 2y. Don't forget, the sign is always to the left of the number. So negative 2y equals 6. Divide and divide. So y equals negative 3. That itself is a separate ordered pair, which is 0, negative 3. When you solve for the intercepts, this x and this y are not an ordered pair together. Do not make that mistake. Not together. They are two completely separate points. Well, for example 2, so after we solve for those intercepts, then they want us to take that same equation, which I forgot to write here, I'm going to write it, 3x minus 2y equals 6, and they want us to graph it. Well, since we already solved for those two ordered pairs, whoops, I'm going to write them down. So we have 2, 0 and 0, negative 3. Well, this is another method of graphing. Once you solve for those two intercepts, we plot them. So this is our x, so positive 2, 0. And then this is our x, this is our y-intercept, negative 3. Together, all you have to do is extend the line, and you've drawn your linear equation. So depending on how your equation is given to you, so this equation was easy to graph using the intercepts. It was not in slope-intercept form. It's not solved for y. Both of these numbers are able to go into 6 evenly. So this was the best method to graph this equation. So depending on how your equation is given to you, you determine what's the best method, whether you make a table, whether you use the intercept method or the next methods that follow. But that's the end of 8.3. Make sure you watch the next videos for 8.4 and on. Bye.